Okay, in this presentation we're going to look at the limits of trigonometric functions, and there's three important identities here. The first is that the limit as x goes to 0. By the way, that's important to remark. These identities apply to the case where the x is approaching 0. The limit of the limit of this function as x approaches 0, the limit of sine of x as x approaches 0 would be a better way of putting it, is 0. The second one is the limit of cos of x as x approaches 0 is 1. And the third one is the limit of tan of x as x approaches 0 is 0. Just as a quick remark, tan is essentially cos divided by, or sine divided by cos, so it actually works out as 0 divided by 1, so it would be pretty intuitive. So let's try this out for a few worked examples. I'm just going to pause it here and write them down. Well, the first example is the limit of this expression here, sine of x minus 1 divided by 2 cos x. And what we're looking for is the limit of that as x approaches infinity. What we're going to do is actually break it up into two parts, above and below. Limit of x as x approaches 0 of sine x minus 1. And we're just going to write 2 times the limit of x as x approaches 0 of cos of x. Okay, essentially the constant term could just be taken out, so it's 2 times the limit of that. This expression here, the top expression, can sort of be broken up into two more parts, which is to say the limit of x of sine of x as x approaches 0 minus the limit of x of 1 as x approaches 0. That's just 1 because it's a constant term. Okay, so this is the numerator here. So that part is going to be 0 just because of our identities earlier on. This part is just going to be 1 because it's not a function of x, it's just constant, so we just leave it back as 1. So I'm just going to rub those out, and we can sort of say now that the top, actually I'll leave them there. The top part of the expression is, so we just like put that there. That's equal to 0 minus 1, and the numerator, the denominator even, is 2 times the limit of cos of x as x approaches 0. That is 2 times 1. So our answer is minus 1 over 2. So that's the answer to the first one. I'm going to pause it now and do a second one. So this is the expression here is cos of x minus 1 over 2 sine x, and we're getting the limit of that expression as x approaches 0. So let's break it up into two parts, above and below. As x approaches 0, we have cos of x minus 1, and the bottom part, the denominator, 2 times the limit of sine of x. Okay. Now, using our identities that we looked at earlier on, cos of x, that is 1. We can just treat the minus 1 part as a constant, so it's 1 minus 1 over 2 times the limit of sine of x, and that is 0. So just writing that out again, that's 1, that's the cos of x part, minus 1, that's the minus 1 part on the numerator, over 2 times 0, and that is 0 divided by 0. Okay, now this is an indeterminate expression here. This is something we can't really work with. So this is just a second part of this recording. So where I just left off there a minute ago was we left with indeterminate answers. So what I'm going to do is actually have a second, use a little trick. So here's the problem again, example 2 again. And what I'm going to do, first off, let me be clear. This approach is only going to work in the basis of x not equal to 0. Okay, so when you're writing your answer for cases x not equal to 0, the reason is that the 2 sine of x, this sine of x matter here, this will always have a divide by 0 problem. Okay, so for these whatever answer you have for this, and I'm going to show you an answer now, it will always have to divide by 0 problem if you let x equal to 0. Okay, so this importantly, this is very important. The solution we're going to give is for cases where x is not equal to 0. Okay, now so here is the expression again, but what I'm going to do here is divide above and below by the same expression. Okay, so I have cos x minus 1 divided by 2 sine of x, and you can just see here, what I'm going to do is multiply above and below by cos of x plus 1. Okay, now there's a slight trick to this, and the trick, if you sort of look, I'll come to it now, you can probably sort of see where it is coming into play at the bottom of the slide. Essentially what you do is we're going to use the sort of difference of squares. This is the difference of squares here. That's the difference of squares formula. A squared minus b squared is a minus b times a plus b. Okay. It is one of a handful of tricks that one might use. But if you have cos x minus 1 or sin x minus 1, something like that, you just sort of think, there's a difference of squares technique I can use here. It's a sort of informed decision. But essentially cos x minus 1, or if you have sin x minus 1, that'd be another case where you might use this difference of squares trick. You divide above and below by cos x plus 1. It's a sort of a bit like simplifying complex numbers, if you're familiar with that. Okay, the complex conjugates and all that. A minus b times a plus b is a squared minus b squared. Okay, so just remember that. That's the sort of important thing to know. But just it actually is on the small matter of correctly multiplying that out. And just this is a trigonometric identity, important trigonometric identity. Okay. Cos squared x plus sine squared x is equal to 1. Okay. Now, those are two important little handy tricks that we're going to use for this. Just as sort of a quick remark. Sorry, I just run ahead of myself here. Cos x minus 1 times cos x plus 1, that's going to be equal to cos squared of x minus 1. I'll actually just make a bit of space here and write that out to get that part there. So just looking at the numerator again, cos x minus 1 times cos x plus 1, the numerator is going to equal cos squared x minus 1. Okay, so that is the numerator, and using this formula below, that's just it stated again. So we have the numerator is cos squared of x minus 1. Just rearranging that formula, you could quickly see that cos squared of x minus 1 is equal to minus sine squared of x. Okay, so the numerator can be written as minus sine squared of x. So we've gone from this expression here, okay, and I'm just going to, is now can be written as this expression here, okay. So the limit of, as x approaches infinity, of minus sine squared of x divided by 2 sine x times cos x plus 1, okay. So that's our expression now. First off, what we could say is that I'm going to delete the highlighting there. The minus sine squared of x divided by sine x, so we can cancel that out a bit. So we could take out the sine x down there, and we'll take out the square there. That's the sine squared of x divided by sine x, just gives you sine x. So, so far so good. Let's just rewrite that here at the side. Actually, I'll leave it as it is. So we have minus sine x over 2 cos x plus 1. Now, we're just going to sort of write our answer in now and finish it off once and for good. Once and for all. That's minus 0. The limit of that is minus 0 over 2 times 1 plus 1. Okay. I mean, minus 0 is just 0. It's a sort of bit of a misnomer, so it's just 0 really. Okay. Over 2 times 2 plus 2, 2 times 1 plus 1 is 2 times 2. It's essentially the answer is 0. It's 0 divided by 4, and the answer is just 0. Okay. And again, when you're answering this, it's just again for cases where x not equal to 0. This limit does not apply in cases where x is equal to 0. So x not equal to 0 is the answer for those cases only. Okay. So, that's the end of that. We've done a good job.